This is a 13 inches MacBook Pro. It's a A1989, and this form factor, which was introduced in 2016. The A1706, that was the 2016-2017 touch bar, and then that was refreshed with A1989, which was sold in 2018-2019. And then with the 2020, obviously, that's when they changed the model number. 2018, 2019 shared the same model number, and 2016, 2017 shared the same model number. And that's obviously the touch bar lines. The non-touch bars was 2016, 2017, which is the A1708, and that was discontinued in 2017. And it was then refreshed in 2019 with a touch bar, and then the design followed up until 2020, when Apple decided to basically into to follow the same design in terms of the top casing of the 16 inches 2019, where you have the escape key being separated from the touch bar. So that was what they then introduced on the 13 inches. That was in 2020. So, but then that was already a design attribute of the 16 inches in 2019. But in 2020, the refreshed version of the non-touch bar of 2019, and then in 2020 that was followed up and also the M1 also followed suit. Okay, so the story behind this was it was said that the client purchased a screen. The device needed a screen replacement. A client purchased a screen. They replaced the screen themselves, and afterwards the device would not power on. So we are expecting to have some kind of a short on the machine because of the backstory. But nonetheless, we cannot say anything for sure until we get into the device and then get to understand what state the device is in. Okay, so as you guys know, the first thing we want to do is take the back plate out. It's important to try to guide your screwdriver. It helps you to minimize scratches at the back of the device, which is your back. Say so scratches like this, for example. So those can easily be caused by a straight screwdriver. One of the ways you can minimize that is by using your fingers to guide your screwdriver. Okay, that is that. And also, whenever you are working on these devices, because of the back plate is almost flushes into the chassis, it's a bit difficult for you to just open after. So you obviously have to find an opening somewhere. So try not to use tools. For myself, I like to use, because of the opening, the opening that we have here. So I like to start from here, which give me an opening, and then I can now. So I do not really use a tool, because sometimes when you use a tool to pry it open, you may not be able to understand, or you may not know the extent of the reach of your tool, and that may go into the device, especially. So most of the mistakes that we have seen is the tool making its way. You find that the tool goes as far as this, and then it basically uh, pull the component from the board, and that is a sensor chip. So let's show you guys what that chip is. And usually when that error happens, the machine boots super slow. So that is U5860, and U5860, you can see that it's RIO TBT. That's a sensor line. So TBT Thunderbolt. So that is a sensor line. So if this chip is broken off of the board, you have your device being super slow. So let's see. You want to make sure that you do not break that off on the board, and you can easily avoid doing that by making sure that you use your hands instead of having to use a tool. And if you do use a tool, make sure you are pretty much in control of the tool. So yes, you still can use a tool, but be sure that you are in control of the tool. And it also helps if you're very familiar with the device itself. So that way you should know how much deep the tool should go. Okay, so I see that also the battery cable seem to be damaged. So not just the screen issue, like they said, also the battery cable here. And then I also see that they have marks all over the device. The screen is marked out, the heatsink is marked out. So battery has been replaced. However, the battery cable needs to be replaced. Okay. So first thing first, we try to go over a bit of a visual inspection. So we can just go ahead and take the board out to make the work easier for us. Yeah, let's just do that. Let's just take the board out to make the work easier for us. Afterwards, I mean, the not only so this board just the client must the client try to do the replacement themselves, and that didn't go well. They brought the device in for repair, and it was then assessed by another company before the device got here. So we're pretty sure that this is definitely like a no power, just like what they have described it as, and they were pretty sure maybe something probably got broken off from the board. So to save us time, we can quickly go ahead and take the board out of the shell to get a better view of what is happening. We can still make the regular measurements we make to check for a short, but because of the backstory, we are more likely drawn to looking out for a broken component that is being broken off. Just because of the backstory. I mean, if it was not the backstory, we would obviously follow our traditional route of checking for a short. That's a wrong screw. That's not supposed to be there. Seem to be one out. We have to get another. Okay, we don't have to worry about that. We can just slide it on the side. Since it's one out, let's get this the cables disconnected. And also, when you're using the tool for your cables, be sure that you have full control over your cables, and be very careful when it comes to your the Touch ID cable, because Touch ID is paired to the board. If you break the cable, it can be fixed by running jumper wires across just to basically fix the damage, but it's a lot of work. It's a lot of work to do, so just try to avoid that. And also, whenever you are taking your board out, be very sure that no you if you have any type of resistance, look to be sure what is resisting. Don't just force it out, because you don't want to break anything, especially in this direction here where you have the touch ID cable. So you want to make sure that the touch ID cable uh, it's properly looking it's probably properly looked out for. So it also seems like the keyboard was replaced. Like, I don't understand. Almost everything is being replaced in this machine. This battery, it's refurbished. Keyboard has been replaced. Screen was replaced, and then now board is dead. I don't. Okay, so cable definitely needs to be replaced. Let's put this on the side. Now let's check the other side of the board. Usually we want to check from the right to the left to see if anything stands out. And also sometimes it could just be a coincidence. It may not be that the issue is has anything to you see. Okay, so although this is not going to have anything to do with our issue, because this section here, but you see see that was basically yanked off. So let's see. This section is for the fan, I believe. Let's just confirm that. Okay, yeah, that is the fan section. So that has nothing to do with that's for the fan section. That has nothing to do with the device powering on. But that is an so you see how that it's basically broken off. So that's not good. We're going to come back to that, but right now we are only going to first worry about this the issue, which is no power. So first we are going to worry about that before uh, this is the covering for the screen screen cable. uh, okay, so we don't see anything other than this, which is not going to play any role in terms of that is not going to prevent the device from starting. So now we can go ahead. The obvious thing I was also looking at for is any bond component around the screen connector, but also a bond connector around the screen connector would obviously will be like a bond inductor, which is going to be on a 5-volt line. Let's see. So that is for the webcam. Then you guys see that. So that the 5-volt line that will be for the webcam, and then if we go the connector, so we have another one which is a 5-volt line as well. That will be, yeah. So that's for the screen, and then the other one will be for the webcam. So we don't see anything that stands out. So since we don't see anything that stands out, let's now go over our regular measurements. First and first, let us start by making measurements on our PP bus. We are going to use a fuse. Usman, you remember what this is, yeah?
Yes,
What is that?
it's a people plus few.
Yeah, that's a fuse on the PP bus line. So, and we say that a fuse will always start with F. So here you have F7000. And then you see, yesterday we were talking about how the fuse is basically in between. So you see on one side, it says PP bus, and then the other side, it says battery. So PPV bat underscore G3H. And so G3H means always on, always present. So what that means is that particular, so whenever you see G3H being attached to a power line, so what that means is that power line must be present at all times. There are some power lines that are not that are subject to the state of the device. But when it comes to G3H, G3H must be present at all times. It doesn't matter if the machine is being powered from a battery or from a charger. And then, as you guys know, there are two main power sources for your board. So it's either from a battery or from a charger. Now, when you see G3H being attached to a description, it's telling you that that line, that particular voltage, or that particular rail must be high at all times. Do you understand? So that is what G3H means. And it also means in newer devices, they use AON, always on. Okay, so let's see if we have a shot on our PP bus. We use our Blackwood to ground, and then our Red Pro. Hmm. Okay, our multimeter, the battery of our multimeter, it's acting up. We'll have to replace that. Okay, that's fine. Let's see. Okay, that's fine. Okay, so what we're going to do, we don't see anything that stands out in terms of a damaged component, or anything that will pose a threat to the device. The next thing we want to do now is to put power to our device, to the board, and then see what we get. So as you guys know, if we measure 12.6 on our PP bus, that will tell us that we have 20 volt on our PPDC in. But if we measure 12 point less than that, 12.33, 32, then that tells us that we have 5 volt on our PPDC in. So let us connect power to it. And then, as you also know, that we need the device, we need 20 volt as a In order for the device to work, your PPDC in must be 20 volt. If you get less than that, that is an issue that needs to be resolved before you will get. So if you get 20 volt, if you get 5 volt instead of 20 volt, then you have to worry. You have to look at the conditions which are the requirements of your 20 volts to be present on the board. If you don't have 20 volts, then you have to first of all resolve that. It doesn't mean that you have to resolve the 20 volt at the section of the 20 volt introduction, which is the PPDC in. I don't know if you understand what I'm trying to say. Yeah. So it doesn't mean that because your 20 volt are going to be managed primarily not independently, primarily by your U3200, which are the CD3215 controllers. Now there are four on this. Why? Because there are four charging ports on the board. Now, if you have 5 volt instead of 20 volt, yes, U3200, which is one of the CD3215, plays a major role. Bear in mind that the whole four they are interdependent. The whole four are interdependent, and also there are working conditions that are attached to the four. For example, your PP3V42 must be present in order for you to have your what is it called your 20 volt. So if in a situation where and your PP3V42 is not primarily generated from your U3200, even though U3200 will play a role. Why is that? Remember, your PP3V42 is going to be created in the midst of your board. At the beginning of your board is going to be your PPDCA, your U3200, which is your CD3215. The voltage that your PP3V42 will be created from or generated from will have to come through your PPDC inline. Do you understand? So say for example, if you have a faulty, let's say you have a faulty CD3215 and it's not even allowing your PPDC in to go to your U7001, which is to go through to create. So if we come, let's just quickly come here. So U7001 is going to be okay. U7 here it says U7000. Now U7000, we will have the U7000 will have the enable signal for our PP3V42. So here charger underscore no, not that's not it. Charger no, yes, that is it. So now let me see. Is this going to be for PP3V42 or PP ROTC? So for some they will use PP3V42 and others will use ROTC. So this is 2018. I suppose it's going to be ROTC. Let's see, charger EN. Yes, this is going to be an ROTC, I believe. Let's see. So U6903, yes, this is going to be ROTC. So now this is basically this is what will this replaces your PP342 creation now, and that is because so in 2018 you need U6900, U6903, which will generate your PP3V3 underscore RTC, which is now being used in place of your PP3V42. Now, that is in 2018, 2019. In 2016, 2017, that's different. In 2016, 2017, let's go to, okay, yeah, that is a 2015, 2017 board. This is a non-touchable A1708. Now, here we have PP3V42, yes? So now it's using PP3V42. Now, this PP3V42 is required for this PP3V42 is required for your PPDC in to be 20 volt. Now, the same chip here, U7000, is also going to send the enable signal for the enable signal. Yeah, we can find the enable signal here. So the enable signal is still going to come from U7000, just like this enable signal for the 2018-2019 is coming from U7000. In 2018-2019, the signal PP3V42 is now being replaced with ROTC. The ROTC, which is still going to be 3.42 volt, basically, which is 3.3. It will now be replaced with ROTC on your 2018 and above. But in 2016, 2017, that is what will be required. So on our 2018, for example, so you see here, you see this signal here, which is still going to come from the enable signal is still going to come from the U7000. So what I was trying to say is this. Now, if you see here where it says PPV in, so that would be the voltage that goes into U6990, for which plays a critical role in creating your PP3V42. Now, PPV in is going to come from PPDC in, which is going to come from your charger, which is going to be managed by your CD3215. Now, if that is not, if you have a 40 CD3215 and it's not allowing PPDC in, even at the basic, even with 5 volt, even with 5 volt, you will be able to get PP3V42. Do you understand? Even with 5 volt here, you'll be able to get PP3V42, provided also you have an enabled signal that is coming from your U7000. So, like, I don't know, I probably lost you guys. Let's go back to where we were. So, what I was trying to say is that if we check here, what I was saying is if we plug our charger in, let's discontinue this. Let's discontinue that. If we plug our charger in and then we're getting 5 volt at our CD3215, we are not going to fully consume ourselves in focusing on the CD3215 input only. We will consider other factors that are connected to the creation of your 20 volt on your PPDC in. For example, like we were talking about the RTC signal in case of your 2018 and 2019, and the case of PP342 in the case of your 2016, 2017. If that is not present, then you will not have 20 volt on your PPDC in. So you are not only going to focus on your CD3215, you also consider other factors that enables the creation of your 20 volt. I don't know if that makes sense. Okay, so let's come here now. So we are now going to connect a charger to this and then see what we get. We have our charger multimeter set to 200 volt. And then also when we're talking about multimeter, so you see, so if I want to measure 1 volt, for example, it's okay for me to set my multimeter to 2 volt. But if I want to measure something greater than 2 volt, then I have to set it to what accommodates my max has to be higher than what I'm measuring. Do you understand? Otherwise, if you use 20 volt, for example, to measure something higher than 20 volt, you get OL. Do you understand? Now PPDC usually are 20 something volt, not just, it doesn't stay, it's not directly on 20 volt. So what that then happens is when you use this to measure your PPDC in voltage, then you will get OL. So if you want to get 20 volt, because it's a little above 20 volt, you have to switch it to 200 volt. Okay. So let's see what we have here. We said if we get 12.6, it means we have PPDC in 20 volt. But if we get 12.3, and then it means we have 5 volt in our PPDC in. 12.6. So that tells us that we have 20 volt on our PPDC in. Let's check another port. Let's be sure you have the same thing. 12.3. 12.6. So 12.3, just that's before it boots into before you get your 20 volt. So you get your 5 volt, and then just say with all of the conditions required being met, then you will get your 20 volt. By the way, it's important if you guys can get this app. It's very helpful. It gives you all of the information that you need on the year of your Mac, when the Mac was introduced and when it was discontinued. You get all of that using a Mac tracker. So it's an app you can get on your iPhone. You can also get that on your Mac. So it's very good. So let's check other. Twelve point three, 12.6, that's fine. Okay, so this seem okay. So, and the fact that I'm also getting this, it also seems like the CPU is warming up, which could mean that, okay, let's just see if we are in SO state. Let's flip. We can check to see if we're in SO by measuring. I'm just going to. Oh, by the way, so I was just saying what I was saying that was because we have 12.6, it means we have 20 volt. Yeah. So if we check here we should be getting, we check on our PPDC in. This is going to be one of our PPDC in fuse here. Let's flip it here where it says FB 200. So that is going to be, and then you see the description there, 20 volt USB-C. So it's a 20.4. And if we are to switch the multimeter to 20 volt, because of the extra 4, so what you get will be OL. Okay, so that's fine. So the next thing we now want to do is we want to see if the device is making it into SO. So we can check an SO line, which is the webcam line. Usman, who was that?
Well, someone asked me an occasion, how can you get in here?
Okay.
I think they said to me, let's go to the reception. They said to me, they will show you.
Where are they?
He just said to me what to come here.
You didn't confirm where they are, no?
Just asked me one time what was in, I say 5.
Okay. Okay, so we can check for to say now here. This is a 5 volt, but this is 5 volt in SO. That's 5 volt in SO. So let us see if that is present. If we find voltage there, so that is indicative that, yeah, that's indicative that the device is actually making its way into, yeah, that's indicative that the device is making its way into SO. Next thing we are going to do is let's connect the screen because it seems the device is perfectly going on. And let's put it screen. There's that screen I gave you, the one that has 20 volt with lines, the A1989 with line Intel. I gave you one. I asked you to test. Okay. Okay, because I know this works. 2018 with lines. Okay. See. So wait, am I getting anything? Nah, nothing. So you see the other time when I was saying that, so this is an example of one of the rail that it's conditionally present by condition. So there has to be a condition required for it to be present. Say for example, you see the 5 volt for your screen. So this that says PPV5 underscore SO underscore SO switch underscore LCD. That rail would only be present when you have the screen connected, and obviously when the device is on. Do you understand? So that rail will never. So you will never find that rail without the screen being connected. Do you understand? So that's just one of those. So that is why it's important to understand why one says G3H. If that rail was G3H, it means regardless of, that is a rail that will be present at all times. Now, with this, for example, now that particular rail, the 5 volt line, the 5 volt now will only be present when the screen is connected. But when the screen is disconnected, you will no longer find that rail to be present. So let's see if we have that, and also the 5 volt also indicates that the screen is detected, because the 3 volt and the 5 volt line are usually requirement for your screen to be detected. If you're, for example, if you're troubleshooting backlight, before you worry about checking to see if you have backlight, see if these two lines are present. If you don't have 5 volt and 3 volt on your, obviously it means that your screen itself is not powered. If your screen is not powered, remember your backlight is dependent on the presence of image. You have to have image. So the screen has to be detected before you can worry about backlight. If you don't have screen detection, then there'll be no backlight. So let's see if we have, let's just say we don't have anything on the screen. This screen is working. We did confirm that the screen is a working screen. Uh, let's see, is the device it on? We are going to check on the inductor for the webcam again. Do we have 5 volt? Yes, we have 5 volt. And then, so this is the line for the 5 volt for the screen, which is going to be this guy here. Even though it's not populated, R5960, we are going to see if we have 5 volt on that line. And that is going to be the, here we use that to measure. So black group on ground, and then red pro. Let's see, and that is 0. Okay, so um, so 0 could also indicate that the device is not even making its way into SO. I thought the device was warming up. Okay, let's just disconnect that and then try again. 0. Let's see. Do we have? Okay, let's try that again. 0, and then the webcam 5 volt. Okay. What about the 3 volt line? Let's check the 3 volt line. The 3 volt line we can measure here. That's also not present. Interesting. Say, okay, does it seem like the device is cycling? Okay, now you have 5 volt and then that. Okay, let's see, do we have a short on our 5 volt line for the screen, or as well as the 3 volt? Let's just see. Especially because they said, I mean, the device stopped working after they replaced the screen. So let's see, do we have a short on our 5 volt line? No, we don't. Do we have a short on 3 volt line to the screen? No, we don't. Uh, okay, so I guess the first thing we want to do is we really want to establish that the device is actually making its way into SO state, because and then another thing we also want to check is if the device is also stuck on recovery. Let's also check that. The cable, the USB-C cables, they were here. So because this is in order to confirm if the device is stuck in recovery, uh, because it's Intel, we are going to utilize the second port. If it was M1, we will be utilizing the first port, and that will also be on your left hand side, not on your right hand side. So then this will be the second port on your left hand side. If you use the right hand side, it's not going to work. Let's connect charger. See if we have so let's open up a configurator 2, see if the device is stuck in recovery. Okay, the device is not stuck in recovery, because if it was, we should be able to pick it up. Let's just confirm that again. Can you flip it? Does it keep nothing? The other side? Nothing. Okay, device is not stuck in recovery. So the next thing we're going to do is we are now going to follow through the power rails to see what is present and what is not present. And then we can also, yeah, let's do that. Let's see what is present and what is not present. Before we do that, let's make a random short measurements. Just to be sure we don't have a short in any of the secondary lines. That's not the short, is because of the metal there. And when you're measuring for a short, you use capacitors. Why? Because capacitors are the ones that will have connection to ground as well as to a line. Um, so this is just random. Okay. That may not be a short. It may just be a line that has low resistance. Let's check what. Let's get a donor board and see what that is. Yeah, it's not a. What is that? Let's check what line is that. Yeah. Okay. So it's the line has a low resistance. Let's just be sure. You know this board to be working. Okay. Yeah, that's definitely. It's the 11 inches for the perfume guy. Yeah. You can direct him. You can direct. Yeah. Okay. Let's continue. Okay. So we don't seem to have any short. The next thing we are going to do now is to see. Okay, so let's look power to it and get to see what is present and what is not present. So we just established we know PV bus is present. That's 12.6. That is fine. Do we have anything? It's 1.8. That's fine. That's fine. What is that? Zero. The other one is zero. Okay. 1.8, and the last one is supposed to be 0.9 as well. This is present, that is present. Okay, let's check what we have on 2.7 line. 2.5, that's okay. 2.5, that is also fine. That's fine. That is fine. So happy people slide. Okay, so let us go over the schematic and get to see what is present and what is not present. So our board view, our board number is 80.00165. Oh, sorry, 80.000.850. Okay, 80.000.850. 80.000.850. It's 80.000.850. There you go. So the way we go about this, we have to locate. So this is a summary of everything on the page. We have to locate where it says power aliases. Power aliases. That's what we are going to be interested in. So where it says power 5 volt and then power, let's say, so power aliases. So we're going to go to 96 and 97, actually 98 including. Okay, so let's go to page 96. So you see, as you obviously huge you have huge information here, but then is that charger connected? So where you want to go to, because we basically want to go over the power rails to see what is present and what is not present, we are going to locate where it says power aliases. So that is going to be on page 96, 97, as well as 98. So we now want to say go to page 96. So we click on go to 96. That will give us the pages of the power rails that we expected to have. Now, some of them will obviously they will vary from state to state, depending on what state the device is in. The ones that you see that will say G3H, those are obviously, they will be the ones that are always present. So here we start by saying PMIC. Here we're expecting to have 1.6 volt. We're pretty much sure that that is present, but for the sake of following the process, let's copy. So what we're now going to do is we'll copy the output of a particular, where you see where it says voltage, this is output. So you see, this is what we're expecting. Now to measure that, now we now need to copy this line here where it says, you see that line, we copy that and then we paste it on the board view, correct? Okay, so wherever it shows up, that is where we are going to measure, and what we're expecting to see there is 1 point what 0 point what did you say, is 0 point something volt. Yes, did you even copy? Okay, yes. So let's go back. Well, you see, this is what we're expecting, 1.6 volts. Okay. 1 point or 0 point? No, it's 1. 1. Oh yeah. So there is 1. So we see that that shows up here. Do you understand what we're doing now? So we basically copy, and then, but obviously we are going to start from the powers, because we want to see, because we don't have power, and then we want to see, we want to follow up with the power structure of the machine. So the first on the line is what we've just copied, and we paste it there. Then this is where it shows up. So all of this, as you know, with the L means what? Inductor. So L are used to they use L to represent inductors. So all of this we should be 1.6. Yes. And also be mindful of a load. So sometimes when you get load on that line, you may get a slight drop on it. So you may not be expecting to have 1.6. Yeah. So let's see what we measure there. So we're supposed to have 1, 2, 3, 4. I believe they're on the same line. So because we may struggle to get our pro, we may struggle to get this under here, we can use the caps, because remember the caps. So this side, if we cannot get to this side, we can get to this side. Yeah. You understand? So we can use we can use the cap to get the information that we need. So we have our black probe on ground, and then we use any of the caps here, uh, 0.9, and that's fine. Remember I was saying, because you should expect to have load on that line. Now, just so that you know, just so that we have a better understanding, where is the other board that we say works, that we confirm that is working? Did we put it back? Is it this one? Okay, so this is the one that works. And this screen. It also helps if you have a donor board, which will help you to troubleshoot. That also helps. So we know this works for sure, and wait for it to power up. Let's just confirm we have power on the board. We should get 12.6. Okay, that's 12.6. Okay, yeah, that's Apple logo. Now let's see here. What do we get? So even though it says 1 point something, now when you get load on that line, it drops. You understand? So that's just something to take note of. This is considerably low because, I mean, this is starting. Remember, that is not starting. So the load to expect on, obviously, the load to expect, I mean, you should expect that when the load, when you get load on the line, then obviously you should expect, yeah, not that it reduces, so to say, it kind of drops, but and also that vary from rail to rail. For example, people was like, it's 12.6, it's going to be 12.6. So you understand? So especially if you are working with a charger only, without battery being introduced. Okay, so let's so we confirm that we have 1 point what there we have 0 0. Let's consider let's see, start 12.6. Let's check, what do we have? 0.51. And that thing, it's almost as though you would think that I mean, the machine is on, because now we're getting, wait, is that fluctuating? Okay, now it's increasing. Okay, yeah, it is definitely increasing. So it is increasing. Okay, yeah, we just know that it's not working, and also we don't need the screen because that will limit our measurements. Let's put the screen on the side. Usman, please let me know when it's time for Sarai, at least 10 minutes before. What time is it? 4:36. Is that correct? It's past Salah time. Okay, we need to go pray now, and then we'll come back, we'll continue. I didn't even. Okay, we're back. We were actually late for this. We, we were not taking note of the time. Okay, so where were we? Where were we? So what we do is we copy. So you to follow through with the parallel, you go to your schematic, you copy, and then you go to your board view, you paste. You understand? Now, how do you know? So this is, what do you copy? You copy. This is the line you copy, and this is the voltage you are expecting. You understand? This is a voltage that you are expecting. Now, also be aware of the description here. For example, here it says PPVDD CPU underscore wake. Now, there is no, for example, SO, for example. So if it says SO attached to this, that would mean that rail will only be present when the device is an SO. Now this SOC, it's not the same as SO. This is system on chip. You understand? Not SOC. We're talking about S and 0, not SO. You understand? So, so here, so we copy that. So we are not, because we already copied this. So this and this are the same thing. You see the equal sign? So this equals this. Now this equals this. So because we already measured this, we're not going to measure this again. We're just going to move on to the next one. And if we check this, we are not going to check that. We just move on to that is how you do it. So what we now need to do is, and obviously because we are measuring for voltage, we must make sure we have charger plugged in. Correct? Do you understand
Yeah,
what
I
I'm saying?
understand that.
What did I say?
You're saying because you want to measure what multimeter you must put the plug in.
Okay. Okay, so let's connect charger. Let's just do basic checks to make sure that our charger is connected. We can see check to see what we have in our PP bus. 12.6. Okay, that's fine. And obviously that also tells us that our PPDC8 it's fine. So let's flip to the other side. We were here. We have confirmed this is present, and then now let's check this to be present as well. We copy that. We come to our board view, and then we paste. Uh, we can measure that. If we don't get room on this side, we can always get room on the other side. Also, please take note of the type of inductor that is used. So you see, so you see this, you see they look different here. This and this, they are all the same thing. This is an inductor. These are also inductors. So with this, you might struggle to get to the pad, but with this, it's easy to get to the pad. So usually when you find when you're dealing with this, it's better to use the caps on the side because obviously it must be the caps that are connected to it. And one of the ways you can confirm that is just by clicking on the pin 2 of it, and then that you can see that okay, all of these are on the same line. So if I do this, Usman, you see what you see, the green means they are all on the same line. Do you understand? So if you see, I click now. So what that means is, if I measure 1 volt here, the same I will get here. Why? Because they are on the same line. So wherever you see that pin, that is where that signal is represented. This signal, wherever you see the green, is represented in where all of you see wherever you find green, it means that signal will be there. So whatever you measure, you should find the same thing here. Okay, let's go back. So did we check this? Is that what we copied and uh, search? So let's just search. So we see that inductor, which is looks like the last one on the line. This guy here, correct? That's supposed to be the last one. Yes, it's this inductor here. So let's see what we have there. And a 0.8. So another thing we can do is we can just have the other board on the side. Though that's just gonna that should just be our reference. But no, it's fine. That's not that's gonna waste our time. Uh, so 1.6. But then what we're measuring is we got 0.8. Okay, yeah, that's about it. That's fine. And then let's move on to the next one. And here, what are we supposed to get? 0.82. So we follow the same thing. We paste. So when we paste, it will show you where that signal is present, and then you go and measure to see if it's there. 0.82. Yeah. Now the whole point of checking is with the one that you don't find. That is your problem now. You see, we are checking. If we find, we move on. If we find, we move on. When we don't find, then we will now do what? That is our problem. We'll now find out why that's not working. Now, so another thing that you can see here, you see, it says sourced from 3.3 G3H, enabled by. Now, what this would mean is, if this is not present, this is not going to be present because this is sourced from this, correct? Here it says, but it also says the same thing, sourced from 3.3 volt, and it says G3H, which means this is a rail that is going to be always present. Now, if this is always present, what it's generated from it will also be always present. Do you understand? You get what I'm saying?
You understand?
Okay. So we have checked this. That's present. That's present. That is present. So did we check this? Yes, we did check that. Now we want to check 1.8 volt. So let's see, 1.8 volt line. We go to search. One 1.8 volt. Now we can check here. That's not populated. We can use this here. We can use this two here. So let's see, black probe on ground and then red probe. And yes, it is present. 1.8 is present. Okay, let's continue the search. We move down the line. Now, because this is present, we are not going to worry about all of this. We just assume they are all, because why? Because they are all what? They are all connected. And then you also see where what you say is source from 3.3 G3H. So we'll move on to the next, which is also now you see the source, you see where it's sourced from. Even though here you see get 1.8 volt, what was this? 1.8 volt. But the signals are not the same. This is 1.8 volt wake signal. Now, this wake signal, they largely have to do with, when you lift your lead and then the device sweep into action. Yeah, so that's 1.8. No, I'm just trying to make a reference so that you get what I'm saying. So here it says is 1.8 also, and this is a different description. This is 1.8. This is PP3 V3 underscore. But then, by the way, you see PMIC. It's a buck. Yeah, PMIC. No, that's a PMIC, and then it's a buck converter, and then you say switch one. Yeah, that's switch two. Now, what usually what that would mean is this and this are going to come from the same chip with different outputs. Same chip with different outputs. So here you have, it says SW and it's a buck converter. So your buck converter, basically what it will do is it will take a high voltage and slice it into a low one. Yeah. You understand? And then you have multiple switch. In the case of this one, you have one, and then you have where it says switch one, you have switch three. So here now it says source from 1.8 volt SLP S2R, and we're supposed to have 1.8 volts. So we do the same thing. We copy. So we double click in our lights, and then we go to our board view, and then we paste. Peter, do you remember how we got to that page? We had to go to power aliases, 96, 97, 98. So we're starting from 96. Yeah. Yeah. So you go to the main page, and then you go to power aliases. You will see it where it says power aliases, and then you open that. Then you now go to you click on go to 96, for example, if that's what it is. From there, you will copy the signal and start pasting. So you're building your way down until you find what is not present, and then you find out what is required for that to not be present. Okay. It's clear so far. Let's go back. Okay, yeah, so we are here. We copied that and then we pasted. So that we're supposed to get that here. So R806, which is going to be this guy here. This guy here. So black probe on ground, and then red probe. 1.8, that's present. Another thing is whenever you're measuring for voltage, be very careful that your probes are precise. You don't want to, you don't want to move. Just be very, very careful that it's precise. You see, for example, I'm measuring 1 point. If you check here now, see this point. I'm measuring here. Beside it is ground. Yeah. If I use my probe to connect both, then that is shorting the line to ground. You understand? So be very, and also always check out for a better room. If you see that you don't have enough room, then look for a different section where you would have enough room. If you don't have enough room there, check for a different section where you have enough room. I mean, you have another line here, another pin here, you have another one. So you check for a different. If you don't have a room in a particular section, check a different section where you have enough room to make your measurements, especially when your voltage is concerned. Not just that, but for again, if you want to be precise, if you're making your measurements, you have to be sure that you're actually making measurements from the right place. You don't want to touch A and B at the same time, and then you will move on thinking that what you get is accurate. You understand? So be very sure that you have enough room for your probe uh, uh, to make a connection to. So that has been confirmed, that is present. So we are not going to worry about all of this now. We move on to 1.8 S5. And by the way, you see they are changing. Still 1.8 volt, but you see they are what? The descriptions are changing, and they are basic. They are coming from. Let's go back. They are coming from the same chip. Yes.
Yeah.
PMIC box switch one. This is switch three. I think we also did SoC PMIC box three. Okay, so let's check that to see if that is present. You don't want to sit. Okay, so let's see if that is present. Like I said, you look for a better room. Okay, we can measure that here, which is on this side. So black probe to brown, and then red probe on the resistor there. Let's see, what do we get? Okay, that's not present. Let's just to be sure that's not present. Let's see, do we see have voltage? Yes, we do. Let's check that again. That is not present. Let's just be sure. So that is R5850. So now 1.8 volt S5 is not present. Yeah. Let's confirm again that that is the case. And then also when you are, be also careful not to use your probe to pull a chip. Do you understand? Also be very wary of that. You don't want to pull a chip. Yeah. Let's do this. And that is not present. Okay, so now when you are making measurements like this, when you find a rail that is not present, after you have confirmed it's not present, the next thing you want to do is what?
Now we need to go to that line.
No, the next thing you want to do is to check if you have a short on that line. That's the next thing. So when you find a rail that is not present,
Check for sure.
first, after you check for short, then you now follow down on the working conditions, which is what is required for that line to be present. So the first thing you do is check for short. So we disconnect, and obviously to check for short, you have to make sure there is what? There is no power on the board, either from the battery or from the charger. Do you understand? Usman, if you don't understand, you say. It's for your own good, because at the end of the day, if you say you understand and we just move on, you will be the one to. So are you following so far? Has there been any break so far? Are you following? Up until this point, you still understand.
There's some but there's one was not clear, but I understand.
Okay. So we are going to check to see if we have a short, and we have disconnect power from the board. Our multimeter is set to continuity mode. We are going to place one probe on ground, and then the other one we check, and we don't get any beep, which would mean we don't have a short. We can just confirm on another board. Okay, let's just confirm reading that. Because another thing is that sometimes you may have a low resistance, even though it doesn't beep, doesn't mean that there's no short. So it's not that you can only detect, you can only confirm a short only when it beeps. No, remember when we talked about the resistance to ground. So the higher it is, the farther away.
Yeah.
So if, for example, even though there is no beep, but you are getting, let's say, 220 on a line that's supposed to be 1,000 plus,
Yeah.
that is a short. I don't know if you understand. Yeah. So don't only expect it to beep, and if it doesn't, which is why it's more accurate, especially in situations like that, to use diode mode instead of continuity mode. Because oftentimes when you are continuity mode is like a quick, it's like a quick process. You just want to go through, just want to go through it. But for accuracy, you want to use diode, because diode mode will give you, you will see the difference in numbers now. In your continuity mode, even though you are listening to the beep, be aware of what you see on your display. Because if it's low, you want to know, no, even though there's no beep, it's not supposed to be low. And that is especially important when you are working on backlight outputs. When you have a short, especially on your newer devices, you may not get a beep, but then the resistance will be low.
So in short, if the best way to measure in such case like this is to
It's
have a board, a similar board which is working, so
no,
that
no,
if you
no,
use a
no,
diode,
no, no, no. So yeah, a similar body it would be it's ideal when you are not quite sure of exactly what you're supposed to get.
yeah,
Then a similar board, yeah, that's number one. Number two, also if you don't have a board view or schematic, that's
okay,
also fine. And then number three, sometimes you may have very sometimes a small number can make a huge difference. And there's something they call tolerance.
yeah,
Tolerance is, for example, if I'm expected to get 1.2 and there's some kind of tolerance to be considered there, if I do get 1.1, it should be fine. And if I do get 1 point, let's say 1.2 something, it should also be fine because of the tolerance that we're looking at now.
yeah,
Now, but at the same time, as that small number, if the small difference can also mean the reason why you're depending on if you're working on a power line on a data line. Do you understand?
yeah.
So yeah, let's
So
not go too
where
deep.
exactly does it give a huge difference? On a data line, if you get like, let's say we are
So
expecting
so
1.2,
so data is more sensitive compared to power
okay,
because power with power you can easily pick it up because if it says 5 volt but you're getting 4.3 volt, you're like nah, that's quite low. But
yeah,
with data, because now you're measuring it with you're using your diode mode on the line that you're getting 0460,
yeah,
and another line you're getting 0465. That may just be a difference in that may just so that difference may not really play a role. However, if you have been able to narrow down where if you have been able to do a narrow down, and then you can confirm that okay, on the non-working board you're getting 0 point,
yeah,
there's a difference of 5. You want to find out why. You want to get another board. Not sometimes you don't rely on even just one donor board. You want to get another one and another one just to be
make
sure
sure,
before you move on. Because the worst form of assessment is when you are wrongly when you confirm wrongly. Because once you miss that window, it closes. You can never get that machine repaired because where you are supposed to, it's more like an exit point. If you mix this exit, all of the you may do like whatever form of whatever options you take afterwards, it just seems as though you are working, but my friend, no, you're lost
yeah,
because you've missed that vital information. So you want to, which is why your multimeter is your ultimate guide, your
yeah,
multimeter as well as your diode, your schematic and your board view. So you want to be sure that you didn't miss it because once you miss it, you will now concentrate on somewhere else.
not the actual,
Yeah, and then however much you concentrate there, you may be able to find a way back to say, nah, man, this is where I missed it. But that will probably take you 3, 4, 5, 6 hours, or even sometimes the whole day. You put the board down and then do something else, and then you come back to it. Okay, so that's it. So where was I? I think I kind of lost track. I was talking about what was I talking about?
we are measuring,
I guess I was talking about yeah, I was talking about how you should not just focus on the beep and also focus on the output that you're getting. So we
yeah,
have confirmed that we do not have short on that line, obviously by using because we didn't get in the beep. So we're getting another board just to confirm that that is the same. So black probe on ground, and then the red probe for that's about what we got here as well. So that should be fine. Wait, 392. Yeah, isn't that what we got?
that is very,
429. And then this is what? 392. Okay, so now this is where we want to use our diode mode. So to just to be sure. And now you see with continuity mode, you have your black probe to ground, but in diode, your red goes to
red to
ground.
brown.
You understand?
Okay, make the difference.
In diode, I switch now, and this is the sign of your diode, correct? You still remember?
Yes,
And then the other sound, the other sign, this one.
Maybe
Yeah, so that's your continuity. Yeah. So I use I place the red on ground, and then this will be my point guide. What do I? And also remember, I also said something like, so. First of all, you confirm, and then you affirm. Then you hold onto it. Yeah. First you confirm, and then you hold.
Yeah.
And you like Usman is very quick. He's just gonna tap and go. You have to hold on to it. You understand? So that is 0.332. Now let's see what we have on the other one. 0.354. So, you know, when I was talking about, so this is that this is not really yeah. I believe that should be fine, because if we check another board, let's see what we get on that board. Yeah, 354. Yeah, and then this was also what, 354. Yeah, 33. Yeah, that's it's fine. And even though this it's way higher. And then, by the way, something else I needed to also mention. Also, sometimes you're reading the absence of certain components on your board will obviously affect the overall output of your reading. Because remember, the diode mode usually what it does is it kind of gives you, it's almost like a wholesome, like a comprehensive output. It will put into consideration all of what is connected on that line. Do you understand?
Yeah.
So obviously, if you remove some, that can affect your end result. So yeah, but that doesn't. So yes, we can confirm that there is no real concern in terms of a short on that line. Now, after we have confirmed that we don't have a short on that line, the next thing we want to do is we now want to go and find out where is that rail generated from. Did you understand the process now? So
Yeah.
first thing first, we narrow down what is not present. After that has been narrowed down, we now check to be sure if we narrow down to the last was 1.8 volt S5, yeah, the net 1.8 volt S5, and then we found that is not being present, correct?
Yeah.
Then the next thing we then had to do was to disconnect power and then see if we have a short on that line. Now, after finding out that we don't have a short, the next thing we now want to do is go find out where that rail or that line or that signal is being generated from, which is where is it created from. That's what we now want to, because remember, yes, now we know it's not present. Now we want to go find out where is it supposed to come from, because the measurements we are making, its output is coming from that line is supposed to come from somewhere. For example, if I measure for PPDC in, Usman, if I measure for PPDC in now, PPDC in, I will measure on this fuse. Yes, PPDC in. Okay. Just see, I'm going to do this. By the way, if you make a mistake by putting your red probe on ground and then black probe as your divider, as basically your guide, you just, nothing will happen except you just have minus on the numbers you get. Do you understand? So I switch to voltage, and then I want to measure PPDC in on. Okay. So I just want to see if I can pick your brain on something. So I do this. What do I get? What is that?
So
Why do you think it's zero?
because the vote is wrong.
What is wrong?
Because you would commit or
So it's not present because where I'm supposed to get that from is not present. It's PPDC in. I'm supposed to get it from
From the cable.
the charger. Now, because that is not present, that is why that's now. Will I will will it make sense for me to blame this as my problem? So what should I do?
If you want to fund, you must put your charger.
No. I need to find out where that is coming from. Charger is just an example. I need to find out where is it coming from. So before I blame, I need to find out where is it coming from. And I also mentioned something. Before you find out where it's coming from, what do you need to do?
Must check the short first.
Exactly. You also want to find out if there is a short on that line. Because if there is a short on that line, everything, whatever is being generated on that line will be making its way to ground. Okay. It's clear so far, yeah? So now what you want to do is you want to see where that is being generated from. So usually you want to go to your schematic. So remember we were here. So here, what does it say? It says source from 1.8 volt, 1.8 volt SLP S2R. So what we now want to do is we are now going to copy this. Remember, we will copy this and go paste on your board view. Yes.
Yeah.
Now we want to copy this and then go paste it on our schematic where it says search. We want to see where that signal is being generated from. Now, you have to please pay attention to this. This is the core of how you troubleshoot and how you read a schematic. This is just how you go about it. If you can get this right, that's it. So now we paste. Now we want to see. Now when we paste, now these are all of the pages where that is found. What we are interested in is where it's being generated from. So we start here. It says found on 23 pages. Now we will start. You have to look out for in and out. You have to look out for what? In and out. Correct? Okay. So let's reduce it a little bit. So for example, you see here where it says out. This tells you that the signal is going out. Okay, you will find the one that also will say in. This says out. You find the ones that will say in. That is obviously where it's making its way in. Now, when you find this is a signal that goes in the board and makes its way from the other side. And they are the same thing.
That's the meaning of that saying.
This one.
Yeah.
So it tells you that it goes, so it's like a signal comes from here, goes in, and then comes out from the other side. But they are the same thing.
Yeah.
Do you understand? Okay. So now we want to see where that signal is being generated from. So I'm just going to go on nest, correct? So I'll click nest. So when I do that, it's obviously taking me to so here, you see, now whenever you see this sign here, that is a sign of an inductor. This one, or a coil. This. This is an inductor. That's a sign of what? Capacitor. You understand?
Yeah.
And this will be resistor. So resistor, inductor, capacitor. And then you see it, this you have C, capacitor, L, inductor, R, yes, R, resistor. Okay, let's continue. Now, here it says we want to see where it's been generated from. So we have this inductor here. We go next. These are all resistors. It's not being generated from there. We're still going. We want to see where it's been generated from. We're still going. We're still going. We're still going. All of this is where it's going into something, most likely. Yeah, it's going into something. Okay. We want to see where it's being generated from. So here we see where it says here. What does it say here? So we have a buck, and of that buck we have one of the output of that buck, it's S3, and then that is where it's being generated from. And what is that chip? We want to go find out what is that chip, and that chip is U7800. Now, after we have confirmed, this is a chip that has multiple outputs, correct? After we have confirmed where it's been generated from, we are not still going to blame it. We now want to see what is the working condition of that chip, which is what is required for that chip to output this. Do you understand? What does this chip need in order for this to be present? This chip is going to have a bunch of inputs as well. It's also going to have enable signal, which is like the switch on and off. Enable is the same, another word for on and off. Yes? Now we know that it's going to be generated from here, correct? Why? Because we see where, because here it says what? Here it says buck, and then it says switch. Yeah? 3. Which means it's going to be generated what? From here, correct? I don't know if it's making sense now, yeah? Now, Yes, go ahead.
I wanted to ask. Yes, I saw that this is where it's generated. But for an example, I saw you saying next, next until we get to this page.
Yeah.
So if I say next,
Yeah.
like right now, I won't see this where it's generated to the next page.
How do you? Now we can continue, and then you can maybe that will answer your question.
Oh, okay.
So we continue. We see continuing. We see continuing. Yeah. We see continuing, and then you also see where you see here PMIC box
Yeah.
switch 3 is also there. Yeah. So. By the way, sometimes the sub this so the sub description will be wrong. For example, here it says 1.5 volt, and then here it says 3.3 volt. So that is wrong. You have to work with this, especially you work with the main. So this is the main, which is now equal to this, which is supposed to be also this. So it's not 3.3 volt. That is wrong. Do you understand? So don't get confused. Okay, how do I have 1.8 and then below that on the same line I'm supposed? No. This is just written wrong. Do you understand? You get what I'm
I
saying?
understand this.
So you worry about this, yeah, and which then equals this. Here you should also have 1.8 without this description. Now you're not going to have power plane, which is the PP. You're not going to have that 1. No, you're just supposed to have 1.8 volt, and also you're not going to have the state. This is S5 so this is the description of the state when that 1.5 volt is to be present. So here it says 3.3 volt. That is wrong. It's not supposed to be that. Okay, so let's continue. I hope this is. I'm just trying to see if that will accommodate the question that you asked.
Yes.
So if we continue now, let's just go back to that page. That was too fast. So here you see where it says E. Yeah, that's where it's going into something. Yes. So those are capacitors. It's not. That's where it's going into a connector. Yes.
Yeah.
Okay. And also that is also so now that is so VCC basically that is where so this is where it's becoming so basically that is also powering so that is U0500 so that is your CPU. Yes, that is the voltage making its way to the CPU. Also you see it here, U0500.
Yeah.
Yeah. Okay, so here it's not the same thing as the switch. Yeah, it doesn't say switch, rather it says VCC. Okay, we just continue. The same thing, the same thing. So
So this is
yeah,
where now
yeah,
it's just
yeah, and then you see the one. I suppose that should be the client for the MacBook Air. Please pick it up. Um, uh, let me. Yeah, go ahead. So this is what it should be. 1.8 volt. No, go ahead. 1.8 volt. 1.8 volt. That's what it should be, not 3.3 volt. Okay,
Yeah.
so now we know where it's supposed to be generated. We know where we're supposed to get it. Name of the building, the box. So so now what we now want to do after we find where it's being generated from, the next thing we want to do is we want to find out what are the working condition. Okay, we missed that. Yeah, what are the working condition of first of all you also want to find out where is U7800. Like you want to sometimes some people may not be able to find you go and pick them. That's if they don't know how to get here. Hey? Okay. So so the after you have been able to narrow down where that signal or power it's been generated from, you want to go and physically see. Sometimes you can just have like a clear answer when you see the chip doesn't look okay. Then you say, okay, yeah, this is my problem, just replace, and then you know you are good to go. So now let's go find out what is U7800. So we now go back to our board view and find out what is U7800. So U7800 is what? It's this. It's this guy here. This is our what? our U7800. So now we said, so U7800 is this is our U7800, and then we said that we are not going to blame U7800 as yet. The next thing we want to do now is we want to find out the working condition of U7800, because if the working conditions are not met, then you will not have the desired output of what, of your U7800. So okay, let's quickly now let's find that out. Now we are using it. Now we want to go back to our schematic, and let's start by checking. So here you see let's see what we get in the voltages that are supposed to go in, correct? So here we know we're supposed to get 3.3 volt on this line. Let us see if we have 3.3 volt on that line. We can measure for this we can copy that signal and paste it, and see if we have 3.3 volt. So we can measure that signal here on the one of those caps, which is going to be, and obviously to do so we have to make sure we have power, because we are measuring for voltage. Yes, we should to make sure we have power on the line. So we can use this guy here.
Yes, boss.
What's how are you?
Good, how are you?
Good, good. M1, the one from Ezekiel.
Ezekiel.
Yeah. So that's yeah, that's we actually that's wrong. We measured the ground pin. This is the 3 point. And then something also you want to also be aware of when you're measuring for voltage also or signal. Be sure that it's not fluctuating. It has to be stable. Do you understand? So if it fluctuates, there's a problem. And oftentimes, sometimes, not oftentimes, sometimes when you get a line fluctuating, it fluctuates because it senses a short down the line, not on that line itself. Yes. So because if it's on the line itself, you will not be able to get the say for example it's 3.3 volt. Yes. So you get 3.3 volt, and then it drops to, then let's say 2 1, and then again it tries to and then it drops. So if the line itself was shorted, you will not get that. You won't get it to be completed, and then it's not going to complete and then go back down. No, it completes. You get 3.3 volt, and then it drops to 1, and then 3.3 volt, and it drops again. So that is an indication that there is a short down the line, not on the, which is a sub rail, a rail that is generated or that is dependent on that rail. When it detects the short, then it basically tries to shut itself down, and then it tries again, and then it detects the short, and then it shuts again, it then goes, and then it tries. So that is so be sure that you have a voltage that is stable, not fluctuating. So we see that is stable. So we have 3.3 volt. That is fine. And another thing we can do to make our job easy is we can just click on this chip. We click on U7800 and then see the voltages that are connected to it. And okay, thank you, boss. Thank you. And then we won't have to worry about having to go that side and that. So we can just do that by we just go ahead and see what are the voltages that we're supposed to get.
From here.
Yeah. We can also do that by going to schematic and see the ins. The ins are going to be the voltages that are required. So the working condition of a particular chip. We can do that, or we can just click and follow through. So which one do you want us to do? Okay, fine. So that is fine. And then another thing is sometimes if you look at your schematic, it's a little bit it gets a bit confusing because it's almost like you're staring at too much information. But when it comes to your board view, it's arranged in a way that you can follow through. Yeah. So what you can do is you can work on both sides. You understand? Yeah. Now we know that 1.1 volt is this voltage is it's to be generated from U7800. Why is that? Because we see that it says switch. Yeah. Yeah, it's to be generated. So what you now want to, so we can check, we have checked that this is present, we confirm that it's present. Then now we can see if no, if 6 is present. The more of these that are missing, the more of the output of that chip that are missing, the more suggestive that there is a problem with the chip. Do you understand? So let's uh, let's check. So we will follow this approach to check here, and then so that it doesn't become too overwhelming. So
So this is better option to
okay, so
check with.
yeah, it's inductor, which is going to be this guy here. Let's see if that is present, and that's present. 1.8. We already checked that to be present. Let's say one. That was a 1. That was 1.1. Let's check the next inductor. By the way, sometimes you can just so for example, you see this, and then you click on the other side. So there's no need to come here because it's going to, if this is present here and it's present here, it's definitely going to be present here because they are connected. Inductor is like a wire. In this case, whatever you get here is what you will get here. So there's no need for us to measure. If we're getting 1.1 here, it means definitely we'll get 1.1 here because they are on the same line. Make sense? So we are not going to worry about the next one. So we did measure this. We are not going to worry about this. So you say switch 0, switch 1, and then switch 0. We're not going to worry about that. We now want to move on to 0.9 volt. Now look at P0V9, correct? That is going to be 0.9. This is 1V1, 1.1. 1V1, 1.1. 3V3, 3.3.
Yeah.
Okay. 0V9, 0.9. So we click on that and see where it appears. It appears here, which is going to be, to locate that, is going to be this inductor here, this guy, yeah? So black group on ground. Let's see, do we have 0.9? Yes, we do have 0.9. Okay, we'll click on the next one. That is a sense line. We are not going to worry about that. That's also a sense line. We're not going to worry about that. This, we're not really going to worry about that now. We'll move on to the next one. Now, this see, this is a line. This is when I was saying that sometimes you want to use a donor board because it's not specified. You see, there is no voltage specification there. So you're not sure what you're supposed to get. So this is where you can use a working board to confirm what it is. So let's see what we measure there. And now, because we cannot get under that component, we are going to use the other side, which is, and then we can confirm obviously by clicking on pin 2, and then we see that disconnected. It also tells us that all of these are the same thing. So if we, whatever we measure here, we're not going to bother measuring the rest. Now, but that is not going to be the rule. In the case of a situation of a liquid damage section, you know that there are chances of breaking parts in the middle. Yeah. So even if you measure this, you want to make sure that the line goes all the way. Okay, so let's check the other side. We're supposed to get 0.9 volt, 0.5. Let's work with that for now, even though, yeah, not precise. Yeah, let's just work with that for now. Okay, because we have a lot of things to go over. So you see what I'm skipping? Yeah, I'm skipping this. Yeah, so you don't. And the reason why I'm skipping this is, for the moment, it's not important now. For the moment, do you understand? Depending on why are we here? Yeah. So why we are here, that's not really what we need for why we are here now. It doesn't mean that it's not important, but for why we are here. Okay. So we are not going to worry about this and this and this. We move on to 24. Now, 24, we've already measured that on pin 6, correct? Yeah. So we move on. We've already measured 25 also on pin 7. So we are not going to worry about it. It's the same. It's the same. PP3, V3 underscore G3 underscore PMU, VDD. Yeah. We are not going to worry about that. This also, we have measured that. We're not going to worry about that. We just measured this now. We're not going to worry about it, correct? Yes? Yeah. The next one, do we have to worry about that? No. Next? 0.9 measure already. Yes, same. If we click on it, we should find our way. No. The description it's a bit different. So this is, yeah, DDR. Whenever I say DDR, obviously that is your what? RAM. DDR. Yeah. Okay. So that, and then the other one is slightly different because it's, this is 1 and this is 0, yeah? We did measure for, wait, what are we saying? What does it say, wake? Wait, uh, no, we didn't. This is what we measured. We didn't measure, did it? Did we? No. That's what we measured. No, we did measure it here on pin 12. No, we didn't. We were not here. So we actually skipped it. And then, oh wait, and 8. Okay. So this we measured,
Yeah. Say if
but we
yeah.
didn't measure this.
No.
Okay. So we now have to go to. So we measured this. We measured this already. We measured that. Yes, and then this we did not measure. We didn't measure that. So that's pin 10. So we count 1, 2, 3, 4. So 1, 2, 3, the third one. So it's going to be 1, 2, 3. Now, if you don't have, because you don't have room, also you can also get a like a very very tiny, maybe like a needle or something. So if you don't have the option, yeah. So 1, 2, 3. So we are going to use the cap. Let's look at the corresponding cap. Corresponding cap will be this, and also the next one also. So which means we can use this because it's on this side because they are connected, so we can use this.
Yeah.
Okay, black probe. Let's see. 0.9. Let's see. And another way you can tell if a chip is failing is if it's heating up excessively. It's one thing to be warm, it's another thing to be heating up. They're not the same. Warm is okay, heating up is not okay. Yeah. So it's not heating up, so that's fine. And we just that was we confirmed that's present, correct? Yeah, that's present. 0.9 volt. Okay, so we can now move on. So that was number 10, correct? Number 11 is present. Number this, no, did we? Yeah, we just confirmed that to be present. Yes, the same thing here.
Yeah.
It's connected from here. Yeah, that is GND. That is ground, correct? That's ground is generally what? 0 volt. That is your reference point. Yes. So it's GND is what? Is your ground, and it's always what? 0. Always what? 0 volt. Okay, so we move on to the next one. We say at the moment that is not really what we are here for. We did measure this and we got 0.5 something volt. Remember we did check that on a working board, and that was about it because yeah. So we're not going to worry about this 3, and then ground. We're not going to worry about ground, and then ground. We're not going to worry about ground. Ground is like you only measure ground, bruh. You living here tomorrow. Okay, so here we did, yes, we confirmed that to be present. Yes, 1.1. You remember? Yeah, we measured that. And then this, we've confirmed that. Yes, we confirmed that. And yes, we've confirmed that. That confirmed. This confirmed. Yes, are you guys following? Confirmed, yeah? Okay, let's move our slide a little bit down. Nothing to, that's ground. Okay, followed. Yeah, this we've confirmed up. Remember?
Yeah.
The
VDD
yeah, we use this capacitor here.
Yeah.
So we're not going to worry about this, all of that. So we're not going to worry about this. Now PCH underscore power button underscore L. So that's PCH underscore. That is the signal. We are not really going to worry about. We worry about that now. Ground, ground, ground. We're not going to worry about this now. We have not measured this, have we? 1.8 volt. Isn't that? Yeah, I think we did measure that before while we were. Okay, let's just check. So that is going to be this guy here because we don't have room. Let's say the corresponding capacitor. Corresponding capacitor is going to be the ones at the back, this 3. So we're supposed to get 1.8 volt. Yes, it is present, 1.8 volt. Um, um, okay, where are we? What number was that?
after PCH.
Okay, so after this 1.8, yes. So this 3 we don't have to worry about that. Then the next one is going to be 55. Yeah, we have confirmed that that is present, yes.
Yeah.
So we're not going to worry about the same signal. And then this, did we confirm that to be present? PMU pvdd main enable. It's that yeah, so we are expecting to have, I mean, we assume that to be present. I mean, if that wasn't present, most of the output that we got, we expect them not to be there. But nonetheless, and usually, so enable signal will probably be 1 point something, 1 point something volt or 3 point something volt. So let's check where that is, and it's going to be here. So if we use this sign here, and then we move a little down, like we see this, and then move this side, then go up. So if we do, so we do this, and then we'll move a little this side, and then we have, so if we move a little to the middle, we have supposed to have that is that, and then 1 2 3 is going to be 1 2 3. And by the way, obviously, you know this, you don't want to use this to to touch anything because there is power on the board. So so that is our main, correct? So our main is going to be this. You see how we kind of find,
Yeah.
so that, and then we do this, and then this as 3.3. So I mean, like I said, I mean, the fact that we got some outputs out, so that is indicative that that is definitely. So we're not going to worry about PMU force DFU, PMU force DF. So we, this is a different thing we talk about, that is to force your board into DFU mode. So that is not, it's not, we're not going to worry about that. That's a feedback line. We're not going to worry about feedback line. For that line especially, like I said, it's not that it's not like it's not important, but for now, because we have that really is present, so let's not worry about that now. There it clearly says unconnected, 62 unconnected. So in a case where it says unconnected, it means if that pin is damaged, that line is damaged, you don't worry because it was never used in the first place. That's what it means by unconnected. Move on to charger CBC on. That is definitely important, but for the purpose but it is important. But for why we are here, we that has already been confirmed. You see, so for why we are here, that has already been confirmed. So it's not something we are going to worry about. And then we know this it's present, and this is present, and we did confirm that 0.9 volt is present, correct? And that is also feedback. So for now, we are not going to worry about that. That we're not going to worry. That's also a feedback line. We're not going to worry about that. We're not also going to worry about sense line. We're not going to worry about this. What line is what? Okay. SOC. We're not going to worry. That's not important to us right now. This that is definitely going to be present because that is just to tell you that PV3 main. Yeah, that is definitely going to be present because that rail is present. So, but then we're just going to double check. But we know that that's definitely present. Yeah, that is present. Let's move on. 1.1. Did we measure that yet? On the other side, we can check. Okay, we can see that on the other side. We can measure that on this resistor here. We're supposed to get 1.1 volt, and then we follow the same system. We look at this cordon here. Okay, we know we can go from here up. We should find it there. So we do this, and then if we go a little this side and then we move up, we should find it. So which would then take us to this guy. Is it this guy here? Let's see. How many are there? 3? No, there are 4. So we have to move up. Seems they are not populated here. Yeah, that's yes. 1 2 3 4 5. So it's 1 2 3 4 5. So that's this one here. This is second one. I don't know if you follow. So it's going to be this one here. Even though the resistor is not there, 1.8. That's fine. We're not worried about that. We're not worried about that. We're not worried about that. For this, yeah, that is also something you have to, because it's not specified, you have to get a donor to confirm what it is. We can just check on our side. So that is this, and it's clearly zero. Yeah, I mean that's PVC CP core. I mean, yeah, we expect, especially expect to have that. That is something you expect when. Okay, so that we did measure that to be present. Yes, you remember?
Yeah.
We checked that's present. That is also present. SOC. Yeah, you're not worried about that. This. Okay, let's see. Do we have that signal present? Most likely, yes, and most likely. So, where are we going to find that? So, that that part is going to be okay. We can use this guy here. Is that a resistor? Yes, R7691. So that's going to be R7691 is going to be this. Is it the first one? Yes, the first one on the top. Yes, that is present. And 97, we can use the one at the bottom. The second one, which is after this, the next one here, yes, 1.7. Yeah, and that's about what it should be. And then 98, we so we know it was this, and then 98 is going to be from here, the top, which is this guy here, and that is not present. Yes, 3.3. Right, is that the pad we're supposed to use? Yes, that's the pad because using this three here. This is a component UB 700, and on top of it you have a pad. So this is that component, the three, and then on top you have the pad. Do you understand?
Yeah.
So we are definitely right, but that is not present. Oh, now it's present. Okay. Oh, you need. Oh, okay. I thought I was seeing zero. Okay. So let's see. Okay, so yeah, that's present. And then 1.8 enable signal. Let's see, is that present? We use the one below. So here we can use this. Yeah, this pin here. Is that present? Yeah, that's present. And you see also what happened is you see sometimes your pad might be a bit dampy, which would then mean that you won't get proper communication. So you want to scratch just to be sure that you get. So before you rule out the to say, oh, there's a problem here, just so that is present, okay. CPU, that's another thing. Let's not worry about that for now. TBG power enable, not now. This, not now, not now, not now. This, we already know all of this is present. Not now. Wait, no. Okay, let's check with that. No, feedback, no, not now. Audio, we're not worried about audio right now. PPVDD, be good. Uh, wait, okay. Uh, okay, so we use these two big caps there, which is going to be this and this. And then in the middle, we have two pads, one and two. So we are just going to use the first one, which means this one here. And that's clearly zero. Let's try. That is zero. See, it seems the board is it's warm on this side. Let me see. It is. U7800 is warm. Let's see. Let's check the T2 chip itself. It's also warm. It's actually getting hot. So what if CPU is getting, yeah, it is getting hot. What if all of this problem is failed due to chip, damage due to chip? This is getting warm, but this, okay, that's not present. PPV enable. Let's not worry about that. Not worry about that for now. Not now. Not now. Not now. Not now. Not now. We're not worried about that now. This we know it's present. Okay. Yeah. That is. Yeah. That's important. But where do we measure it from? Do we say 132? Ah, there's no patch. Okay. Yeah, it's fine. PCH. Okay. Wireless. We're not ready. Like wireless enable. We're not. Vision doesn't power on, so Bluetooth power enabled. That also we're not interested. PMU active ready charger, not now. Wireless, not now. Sensor, not now. SC, not now. This we confirm is present, yeah?
Yeah, 87 was not connected.
Yes. Yes, we're not gonna. We can also extend this out if you want to see more of the description. Ground. We did confirm this to be okay. We didn't. I think we did check that and it's not present. Yeah, we can check again. So it's just the second to the last inductor, which is this guy here. Yeah, it's not present. And then the other one, I believe they are on the same line. Yeah, they are. And that is 162. Is it? Wait, 160. Okay, let's 160. Yeah, 160. Okay, not now. Ground or true. Not now. Not now. Not now. This is what we just checked now, and it's not present. Yes. Yes. This one. We just checked this now, which was here. No. Okay, no, not that one. No, this one. Yeah, 160. Yes, and it's not present. 61, 62, the same thing, and then 63. No, we didn't check that. We only checked this. Let's check that. 63. Which is this? 0.85. Yeah, that's about it. 64, 65 should be the same thing. UPC, PM reset, none at the moment. We're not really ready about. Not now, not now, not now. Also flag would not now. PMU voted not now, not now. Not to confirm it's present. This that's really not gonna help us now. Do your call. Uh, uh, let's see. So it's gonna be this here. 1.8. Yes. We're not ready yet. Not yet. We don't need PMU code reset now. No. Feedback. Okay. I think we did that line already. 196. This chip got a lot of. Yeah, that's not. We did check that it's not present. So we did check. Yeah, it's not present. Uh, yeah, the T2 chip, it's really heating up. Not intense, but Okay, so let's see 199. We can measure that on second to the last inductor, which is this 0.8. Yeah, that's fine. So 200, 201, the same thing. 202. No, PMC. Yeah, that I believe is present, which is going to be, yes, it's here. Yeah, that is present. SPMI data clock. We're not really going to worry about that. SPMI clock and data unconnected. ITC power line. It's ITC. I suppose that is present. Let's see. This is definitely important. Let's see if that is present. The two big caps, we go on top of them to find, so it's going to be these two caps. We go up and should be that one, correct? Should be this one here. That's the pad. Yeah, that's so the T2 chip is acting now. Yeah, it is. It's though warming up it's okay, but heating up it's not. Yes, CPU, PML and off, PMVDD, and that is definitely going to be present. That's definitely going to be present. We can confirm that here. Yeah, that is present. PMVDD max. Not at the moment, not interested. 53B3S5. We expect that to be present as, wait, no, I think we're missing S5. Can you let's check the other side? Easy. Okay, we can get. You see, sometimes you see on one side you may not get many places to measure from, but when you switch the board to the other side, you get multiple places to measure from. So U4801. Let's check U4801. We can get a room there. U4801 will be this. This is U4801, and then the first pin on my right. Yeah, because we know S5 is, and then PP3 underscore S5 is also obviously, as we know, is also one of. So remember the state is S5, correct?
Yeah.
So we know that 1.8 volt S5 is not present. So definitely all of the S5s will not be present. Okay, so that is not present. This is present. That is present. That is present. Okay, so. Mm, This is present. Did you confirm that's a present? 2239. Let's see. On the other side. Okay, we can easily measure from the side. So say top here. So that will be here. The top will be that. So view it. The capacitor, which is going to be this, and this is the pad. Yes. So yeah, and that is present. 3.3 volt. We have already confirmed. Now we don't have to. I think we did confirm that this is present, unconnected. Unconnected 240. Yeah, unconnected 240. Ground. Nah, not really, not really, not really. We already confirmed this. Did we not confirm that? Yeah, we confirmed it's not present. It's not connected. NC unconnected, ground. All of this we confirmed already. The chip's got a lot of pins. This was this present. We confirmed that. Yeah. Yes. Yes. It was confirmed to be present. We're not ready for that. One point. Yeah. We know it's not present. 1.3 S3 S5. What we're missing is S5 S3. Let's quickly check that. So that will be this guy here. and we can check this pin here. And S3 is also not present. Yeah. Okay. Uh, okay. Uh, this we confirm is present. G3 PP3V3 underscore G3H is definitely present. Wait, that is definitely present. That's definitely present, correct? I mean, it has to be present. I mean, we have 20 volt on our, so let's see. Yeah, and it's present 3.3, 1.8 volt. We already confirmed that's a present, yes? 1.8, it is present, yeah? And then 1.8, it's sleep. Was that confirmed?
Sleep 2R.
We can just confirm it again. We use this here. We use this on this side. Yes, it is present. Follow, that is the same thing. 1.8. Okay, 1 volt. Yeah, that is not present. That's not present. Okay, I think we almost end. That's present, 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 not present, definitely not present. Wait. Uh, yeah, it wasn't present. Yeah, we can just confirm that again. So it's going to be this two. This is that, and then beside it is going to be this here. Yes. So yeah, and that's 0 volt. And this is present, this is present, this is present, this is not, we didn't check yet. Okay, so that we can find here these two caps, and then we can measure it here. 1.2 is present. PMU is not RTC 1.8 in 1.8 S3, no, that is not present. We did check 1.8 S3 because S3, yeah, we did check, and it wasn't present. We can just check again, but we confirm that it wasn't present, which is going to be this. Yeah, it's 0 volt. And then that we that's present, S5 1.8 definitely not present. That's S5 is not present, and 1.1 is present, and the last is 0.8. Let's see, the last is 0.8. 0.8 is that present. Let's see, is that present? 0.8. Okay, here. Yeah, that's about it. Okay, so at this point, we are left with two options. Behind door number one, we can go ahead and replace E7800 and see if that will solve our problem. But it's very unlikely. Okay, I can't. Let's not say that. Let's not say unlikely. But the fact that so the TT chip heating up might just be because of E7800, and it may also be because